This is an A-frame problem. We have a vertical load that's 100 pounds, and then I have a strut here and a strut here. It's pretty clear with the vertical load acting downward that this guy and both of these guys are going to be in compression. On the other hand, if P was pulling upward, then it would be pulling on this guy and pulling on this guy, so these guys would be in tension. So again, when you have a strut, here it's in compression, here it's in compression, here it's in compression, but you could also have strut problems where, just like these cable problems with the weight acting down, that you could replace these cables with struts and pull downward on these, then this guy would be in tension and tension. So a strut can be in both tension or compression. But in this case, they're both in compression. Strut ABX 30 degrees from vertical. Strut ACX 15 degrees from vertical. If I draw the free body diagram of the pin at A, then I have the P acting downward, which is 100 pounds. I have FAB, which acts at 30 degrees from vertical, and it's pushing because he's in compression. And then I have FAC, he's pushing at the pin, and he's 15 degrees from vertical. I basically have two unknowns, and I can write two equations for A. So I can sum forces in the X and Y directions, but I can also rotate the coordinate systems just for kicks. And so both are options for me. So just to start with, let's rotate the coordinate system. So let's take this direction to be X prime, and then 90 degrees from it is Y prime. The total angle here is 45 degrees, which means that this is 45 degrees here. This is 30 degrees from vertical, which means this is 30 degrees here. So if we sum forces in the Y prime direction, I have FAC sine of 45 minus 100 sine of 30 is equal to 0 in the Y prime direction. This guy acts perpendicular to that. You get FAC is 50 over 0.707, which is 70.7 pounds is FAC. And that's in compression because he's pushing on the pin. Once you find FAC, then you can sum forces in the X prime direction this way, or you could actually sum forces in the X direction, or you could sum forces in the Y direction. So you got multiple equations that you could choose. I summed in the X prime, which is actually harder, but I've got FAB plus FAC sine 45 minus 100 cosine 30 is equal to 0, and FAB is 36.6 pounds compression. So I can rotate coordinate systems and not have to use a matrix solution. Or I can just write a matrix. I mean, once you're good at writing matrices, it's not hard. And so in the X direction, I've got FAB sine 30 minus FAC sine 15 is equal to 0. So sine 30 minus sine 15. In the vertical direction, I've got FAB cosine 30 plus plus FAC cosine 15 minus 100 is equal to 0. So cosine 30, cosine 15 minus 100, bring that to the right-hand side, it's positive 100. This is my matrix. Sine 30 is 0.5 minus sine 15 is this guy. Cosine 30 is 0.866. Cosine 15 is 0.9659. And I've got a 0 to 100 on the right-hand side. So solve the matrix. You get FAB as 36.6 pounds compression, and FAC is 70.7 pounds. So you get the same answer both ways. Statics works. And if you know how to use it, it helps you. So you've got the complete choice. You can rotate the coordinate system to analyze the joint today, or you can use the XY system to analyze that joint. Either way, you get the same answers.